Lesson 10.4 is about an ideal called the common logarithm, or common log. Now, if you remember back to radicals, if we wanted like the cubic root of x, we always had to put in this extra index, this 3 here. But if we just wanted the square root of x, we don't actually have to write 2 there. Even though it's just kind of implied, we know that we actually just say radical x, or square root of x. Same thing with logarithms. The implied or normal base, if we just said log of 6, what that actually means is log base 10 of 6. So it's just kind of that hidden index here. So if we wanted to find log base 10 of 6, remember this means log base 10 of 6, if you go into your calculator and we just type in log, oops, I guess I would have to put in 6 log, so it's the log base 10 of 6, or log 6, we would have our answer of 0.778. And again, that's just by strictly plugging it into a calculator and finding it out. So in this next one, if we wanted log of 0.35 or 0.35, again, remember that means log base 10 of 0.35. So we do log. In your calculator, you might want to punch log first and then put in the 0.35 if you're using a graphing calculator. But again, from our calculator, we get that it is approximately negative 0.456. So that was given straight from our calculators. Thanks, calculators. So let's move on to a couple of these examples. If we wanted to solve 5 to the x power equals 62, well, let's convert that to a logarithmic form. So essentially what that's saying is log base 5 of 62 equals x. But at this point, that doesn't really help us a whole lot. That doesn't get us anywhere. But we know if we take the log of both sides, we can do that in math and algebra, keeping everything balanced. We can do log base 10, or just log of 5 to the x equals log 62. That's legal. We can totally do that. Now at this point, from our properties, we can take the x and put it out front and say x times log 5 equals log 62. Now to solve for x, we just divide both sides by the log of log 5, and we'd say x equals log 62 over log 5. Punch that into your calculator, log 62 divided by log 5, and we would get then that x equals, it's approximately 2.564. So again, thank goodness for those calculators. So similarly, if we have it set up 3 to the x power equals 17, let's just again take the log of both sides. Log of 3 to the x equals log 17, which means then x times log of 3 equals log of 17. And we can divide both sides by log of 3, log 17 over log 3, which means in the end that x equals log 17 over log 3 is approximately 2.579. Well, running out of room on these ones. Let's give us a little more space. So if we are doing the same thing, but instead of using equations, we have these inequalities. Same exact thing is going to happen, except we just have to remember flipping the sign if we ever multiply or divide by a negative. That's really the only thing that's going to change. So first step, take the log of both sides. Log of 5 to the 3x less than log of 10 to the x minus 2. I'm putting it in parentheses just so I remember that it's that whole thing. It's log of 10 to the power of x minus 2. Now our properties allow us to bring those out to the front. So 3 times x times the log of 5 is less than x minus 2 log of 10. Now remember, these are base 10. This is like log base 10 of 10. And log base 10 of 10 is actually 1. So we can just kind of get rid of this one. And we would then just say that it's 3x times log base 10 of 5. And from our calculator, we know that log base 10 of 5 is actually 0.699. So when I do 0.699 times 3, we actually over here have 2.097x is less than x minus 2. So let's subtract x from both sides, and we would then have, oops, let me pick a different color, 1.097x is less than negative 2. Divide both sides by that 1.097, and in the end we get, I'm going to do it right here, x is less than negative 1.823. Solution to our inequality. Looks like we're taking up a lot of space on these. Let's give us a little more. So just like before, start off by taking the log of both sides. Log. Now again, I'm going to put these in parentheses just so I know where I'm at with everything. Again, go to our properties. We can pull the 7x out front. Say 7x log 2 is greater than 5x minus 3 log 3. From my calculator, I know that log of 2, or log base 10 of 2, is actually 0.301, and log base 10 of 3 is actually 0.477. Again, these are approximate numbers. So if we multiply 0.31 times 7, that actually gives us 2.107x is greater than, in this case I have to distribute the 0.477 to the 5 and to the negative 3. So we would have 2.385x minus 1.4431. So again, we know how to solve inequalities like this. We just have to solve for our x value. So we would subtract 2.385x from both sides, which would leave us with negative 0.278x is greater than negative 1.431. Now at this point I would divide both sides by this negative 0.278. And remember, whenever I divide by a negative, flip the sign. So x is less than 5.147. Solution to our inequality. So, general form of the change of base formula. If we are ever given log base b of u, well, we can say that it's the same as log base a of u over log base a of b. For any number that we pick for a, we can choose what it is there. Again, that's assuming u and b were already given to us. Well, then we can pick what we want our value a to be, which is very useful if we pick a to be 10, because then we can just change it to a common logarithm over here and say that it's log u over log b, which is nice because our calculators always use log base 10. That's just the log button. So again, that would, for example, look something like this. If we had log base a of n, that would be log base b of n over log base b of a. So if we had log base 5 of 12, we could say log base 10 of 12 over log base 10 of 5, which in our calculator would just look like log 12 over log 5. Nice and easy. So let's do some examples of these on our own. If we had log base 2 of 20, we can change that to log base, or oops, just log 20 over log 2. Plug that into our calculator. Log 20 over log 2, and that's the same as 4.3 0.219. Again, that's to 4 decimal places, because that's what it asked for here. Do that one more time. If we have log base 3 of 18, that's the same as log 18 over log 3, which in the end means plugging that into our calculator gives us 2.6309 as our value. So remember, these properties are going to be very, very helpful when working with logarithms. So stay golden.